Hello everyone, welcome back to our channel. Today we are going to talk about caching, okay? So let's have a retrospect of what we talked before. It's a 3-layer architecture for a system, a typical system, right? So first we have the client-side app or website, and then we have the web servers, which can accept the request from the client and then process the request, right? And often we will also have database behind the web servers, so we can store the data and then retrieve them after we storing the data, right? So this is a 3-tier layer. Okay, so basically you can see all the data in this case are stored in databases, right? And in previous session, in previous videos, we talked about 2 different kinds of databases, right? One is SQL database or relational database, and the other one is NoSQL database or just a non-SQL database, right? So, but no matter which kind of database you use, it's database, right? So basically, with database, you store the data permanently on hard disks or SSD, right? On some physical disks, right? So that's how we permanently store the data, and then that's why we can retrieve the data back, right? Okay, with this, you can imagine, okay, so for every request, let's say whenever you need to retrieve a user's profile information, including his name, his preference, or even a post's info, right? So whenever you need those information, whenever a new request comes, you will always go to database to retrieve those information, right? Yeah, there's no problem with this. However, there could be some bottlenecks or some minor problems. The first one is that you always hit the database, right? So the database has to handle a lot of transactions, has to handle a lot of requests from the web servers, right? So the database could become a bottleneck, or maybe it doesn't have so much bandwidth or resources to process so many requests, right? This is the first thing. Second thing is that because all the data usually are stored on hard drives, right? Reading them from the hard drives or even SSDs, right? It takes time, right? It's much slower, right? So basically the performance would be a bad thing, right? Especially if you also have some joins between different tables, right? So for example, in a request, you want to get posts, but also you want to get a post's comments, right? The comments on this post. So this means you have to join 2 tables, right? One is a post table, which stores the post title, the post creation time, the author of the post, right? On the other hand, we have another table, which is a comments table, where we store the comments for all the posts, right? So you have to join these 2 tables to get the whole information to return to the client, right? So this is much slower, right? And also because you have to read data for 2 tables and then do some computation to join the tables, it's way more slower, right? So how do we handle this, right? So basically the way we handle this is we introduce another layer between the web server and the databases, which is, so here, let's remove these lines. So this is database. And another layer is cache, okay? So basically, okay, so the web servers now, instead of sending request directly to the web server, to the database, now it sends a request to the cache, okay? So the web servers now, they all send the request to the cache first. And then the cache is in charge of returning data, right? So this is cache layer, okay? And also the cache layer, if the data is not in cache, it will go to database to actually fetch the data from the hard drives, right? So basically, why do we need this layer, right? So as we said, it's because of performance, right? So because reading from cache is much faster than reading databases. So why it's faster, right? You may ask, why it's faster? Because the reason is because in database, the data are stored in hard drives, right? Or SSDs, or some other system, for example, very old system, or for some cold storage. They may even use tapes to store those data, right? So, but anyway, it's stored on some physical drives, right? Physical hardware. And reading from the hardware is very slow. Usually, for example, if you read from a hard drive for a typical read, which could be 1K or 2K, right? So basically, it will take about 50 to 150 microseconds. Okay, so this is a typical time to read from the hard drive. Okay, but how about cache? Why cache is faster? Cache doesn't store the data on a hard drive. It doesn't store it on physical hard drives or SSDs. It actually stores the data in memory, right? So basically, all the data are stored in memory, okay? And reading data, for example, for the same 1K or 2K data, typically reading from the memory is much faster. It usually takes about 50 to 100 nanoseconds, okay? And if you compare nanoseconds and microseconds, it's 1,000 times faster, right? So that's why reading from memory is faster, right? So that's why we can catch the data in this cache layer, right? So let's say, for example, when a request comes, which is, okay, I want to get this user's profile, including the profile image, the user's name, the user's gender, the user's birthday or something. Yes, first, the data is not in cache, right? So then the cache sends the request to database. Okay, database read the data, right, for the user, and then the data is returned from database to cache. And then cache just stores it in memory, and then return the response to the client. And next time when some other clients or when some other services, they need this same user's profile information, then they just they send a request to cache. Oh, now the data is in cache, it's in memory, right? So now this time we just return the data from the memory and return it to the client or other services, right? So with this, we don't need to send request to database anymore, and the performance is 1,000 times faster than reading from database, right? So that's why we need this cache layer, and that's why the cache is fast. Okay, cool. Okay, another thing you may ask is, okay, I know I can catch things in cache, okay? But what data could I catch in the cache layer? So what should I catch, right? So the answer is you can catch anything you want. And it really, really depends on your use case and on your business requirement, right? So but from the high level, you can catch if we talk about database, okay? Because here you can see the backend is a database, right? So for database, usually there are two ways to catch things. I mean, two methodologies to do the catching, right? Again, you can catch anything you want from the database, depend on your use case. But from the high level, there are two ways you can store the data. Okay, so the first way is you can catch the whole response for a database request. Okay, cool. So now let's say we have a use case, which is, okay, now I want to query a user's posts in the last 30 days, okay? So this is a query which will be sent to the database, okay? So now the database returns the data, okay? So the data it returns could be, okay, so here is post ID 1, and here is post title 1, and here is a post text 1, and here is the post image 1, and some other information, right? Similarly, there will also be other posts returned, right? So for example, we also return post ID 2, post title 2, post text 2, and post image 2, right? So, and maybe there are other, let's say, there are 12 other posts returned, right? So basically, these 14 posts returned are the posts which are created by the user in the last 30 days, right? So there are, how do we catch this? Okay, we want to catch the data, right, in memory. So how do we catch this? So there are several ways we can, there are from the high level, there are two ways to do this. The first way is very simple, right? So first, just catch the whole response, right? So basically, for example, here in the catch, we can see, okay, the key in the catch basically is a hash map, right? So basically, there's a key and there's a value. So for the key, you can see it is the user ID, right? The current user's ID. And then the value is all posts in last 30 days. Okay, so here is a key, here is a value, right? So you catch. So in our previous case, basically you catch all the 14 posts as a value for this specific user, right? And then next time, when the user comes back from a different session, or another user is looking at this user's timeline on the website, then it sends another request, which requests all the posts in the last 30 days, right? So because we already cached this data in this catch layer, so then we don't need to read from database, and we just return this whole 14 posts back to the client, right? So this is the first way to catch, which is catch the whole response. Okay, cool. There is also the second way to catch data, which is catch the, we break down the response and catch single item in the response. Okay, what does this mean? Okay, still taking the previous example. So besides, yes, first, yeah, we definitely need to catch based on user ID and all the 14 posts in the last 30 days, right? But besides this, we also catch the 14 posts based on their post ID. So here, let's say, okay, now the key is post ID, okay? And then the value is the post information or metadata for a single post, right? So this is a key and this is a value, okay? So basically for previous example, because we have 14 posts, that means we will catch 14 entries in the cache, right? So key is post ID and the value is the information or metadata about this post ID, okay? Okay, so you will ask, why? Why do we do this, right? Because with this, you can support many other use cases which you definitely will encounter, right? So let's say, for example, okay, so in previous example, we said, okay, for a current user, we want to get all the posts in the last 30 days. No problems, we cached it. But there could also be another use case, which is, okay, so let's say in our product, a user shares another user's database. Let's say here we catch the user X data, right? And for this post ID, okay, it's post ID, let's say C, okay, post ID C, okay. So now there is another user, okay, which is user Y. In the product, he shares, okay, user Y shared user X post, which is post ID C, okay? So he shared this post, right? So basically in user Y's personal page or personal timeline page, right? It will show the shared post, which is from user X, right? So in order to show this shared post, we need to know post ID C's information, right? So in this case, we want to know, okay, what is the metadata for post ID C, right? Remember, this post is not created by user Y, it's created by user X. It's just user Y shared user X post in his own timeline, right? Now we are showing this post in user Y's timeline. So, and we only know, the only information we know is that, okay, it's a post ID C, right? So now we need to get this post information. So in this case, we want to get the post information based on post ID, right? So with this kind of cache, so basically during previous load of user X recent posts in recent 30 days, we already cached post ID C's data in the cache, right? So now for user Y, if we want to get user ID, post ID C's information, we don't need to query the database again. We just read from the existing cache based on the ID, which is post ID C, right? So let's say in the previous request, which is to load user X last 30 days data, let's say we only catch user X, the 14 posts he has, and we don't catch the post ID. We don't catch based on post ID, so there's no such data in the cache, okay? Then if we want to get post ID C's information, we definitely need to go to the database, right? Because it's not in the cache, right? So now it's an extra burden for the cache, right? And there's no need because you already loaded post ID C information in when you load user X posts, right? So that's a benefit of this, right? So, okay, so this is these are the two ways to catch the data from database, right? Of course, based on your user case, you would definitely have many other methodologies or mechanisms to catch the data, or different kinds of breaking down the cache, the data, right? So I want to catch this part of the data and catch those part of the data. There are more complex combinations, but from the very, very high level, these are the two very basic mechanisms to catch the data, okay? Okay, cool. So we talked about we can place the cache between the web server and also the database, right? But is there any other place we can catch the data? Yes, if you think about it, if you just look at this picture, what other place you can place the cache? Okay, cool. First, we can also put a cache on client side, right? So let's say, yes, we loaded, because on client side, let's say it's a mobile app, right? So I logged in as my own account. Okay, I logged in with my own account. And definitely I have my own profile, right? Including my username, my gender, maybe my birthday, all the information I will show on the mobile app for myself, right? So this information, is it necessary to fetch this information every time from server? So for example, whenever I open a mobile app, do I need to send a request to the web server to get the profile information? Especially if the profile information rarely changes, right? Because my birthday, my name, and my age, they usually doesn't change, right? So in that case, actually we can have a cache on mobile side, which is, okay, I just catch the current logged in user's profile. So whenever I goes into the profile page or the Me tab or something, so I never need to send a request to web server, right? I just read it from the cache on my mobile, right? So this is a cache in the mobile client, right? And in this case, the cache, it's also a cache, but the cache doesn't necessarily to be a memory, right? Like the server side, we said the cache is in memory, but on mobile, it could be your mobile disk, right? Or your mobile, your mobile's physical drive or something, right? Or your PC's drive or something. So basically, it's the reason why we call it cache is because it's not the original data. Remember, the original data is in the database, right? It's just a copy of the original data, and it can give us much, much higher performance, right? So even on the client, you don't catch it in the memory, in the actual memory, even you just catch it on the disk, it's still a cache, because it's a copy of the original data, right? And it can give you much higher performance, right? Okay, so this is catching data on client. Okay, is there any other place we can catch the data? Cool. If you look at this picture, actually we can also put a catch between the client and the web server. Okay, especially if you consider, let's say it's a video file or something. Let's say you are watching Netflix. Okay, so Netflix, you are watching a video or something, right? If without any cache, okay, so basically you need to send a request to Netflix web server, and the web server needs to stream back the video file to you, right? So what if the file, the web server of Netflix is in US, while the client or the user currently watching the movie is in, let's say, in India, okay? You can imagine the traffic will be it's a very long distance on the network, right? So the delay will be very high. It will have a very, very bad experience for streaming, right? So that's why you could also put a cache between client and the web server. So basically, when you stream the video, you don't need to send a request to the web server. You just stream or download or stream the video from the cache layer in between the client and the web server. And this cache could be very close to the India country, right? So then it can give the client a good performance, right? And usually we call this cache between the client and the web server as content delivery network, or just the CDN, okay? We will talk about CDN and how it works in our next video. But for the purpose of a high-level big picture, we put it here because this is also where you can put the cache, right? Okay, so in summary, there are 3 ways we can put the cache, right? We can place a cache. First is we place a cache between a database and the web server of our business, right? Second, we can put a cache on the client side, right? And the last way to do it is to put the cache between the client and our web server, right? Which is called content delivery network. Okay, cool. So these are the 3 ways to place the cache, okay? Now let's talk about one more topic, which is, okay, I understand. Okay, we need a cache either between the database and web server or at some other places. Okay, and we also talked about the 2 ways to store the cache data from the database. Now let's talk about some mechanisms within the cache itself, how it can catch data, right? So basically, okay, let's write it down. So mechanisms to catch data within the caching layer, okay? So we will talk about basically 5 or 6 different mechanisms to catch the data. The first mechanism is called catch aside, okay? So what is catch aside? So basically, okay, let's still take the picture, okay? I will copy it here. Okay, cool. So this is a 3-layer, right? This is a web server, this is cache, this is database. Okay, cool. Cache aside means the cache is aside. It's not between the database and the servers. Okay, so here the cache is aside of the database and the server, right? Okay, so how it works? So basically, when the web server needs to read some data, it first go to check the cache. Okay, so first I check the cache to see whether the data is in the cache or not. If the data is not in cache, then the database sends a read request, okay? Read DB, okay? And then after the database returns the data, the application itself will then send a different request to write the data it read from database to the cache, okay? Write to cache, okay? So this is what happens, right? And then next time, when the same request go to the web server, it will send the request to check the cache again. And then this time it's in cache, and then it just returns, right? So you can see here it's always the application or the web server's responsibility to read the cache and write to the cache, right? So the data update in cache itself is always done by the application or by the web servers, right? So it's aside, it's aside from the web server and the database, right? So this is the cache aside mechanism, okay? Okay, cool. And the second mechanism is called write through, okay? So this is a second mechanism, okay? So this is called write through. Okay, so let's still take these pictures here. Okay, cool. So we have web servers, and now with write through mode or mechanism, so the cache now is actually between the database and the web server, okay? Cool, so in this case, the request is always sent to the cache first. So here is the cache. The request is always sent to cache, okay? And also the cache will also send a request to database to read the data or write the data, okay? And the reason why it's called write through is because, okay, so let's say the current database, the current web server needs to write some data. Okay, so let's say I need to write a new created post to the database by the user, right? So there's a new post created. So then the web server will send the data to cache. So the cache now will just store the data, store the new post data in cache itself. And then the cache will send the write request to the database. And then database also write it to the database itself, right? So in this case, you can see that on the write path, the data is written through the cache, right? So the data is written in cache, and also at the same time is written in the database. So this is called write through mechanism, right? And the third mechanism is called write back. Okay, what is write back? So basically it's very similar to write through, okay? It's just there's a little difference, which is, okay, now the web server needs to write the data, right? So first it write data to this cache, okay? Now cache will write the data into itself, into the memory, right? But it then will immediately send a response back to the web server, okay? It sends the response back to server to say, okay, now your data is written. So the cache is already have the data, and then it sends back the request, sends back a response to the web server, okay? And then later, when the cache is free or when the cache has some thread which can write the data to the database, then it sends a write request to the database. So basically you can see it's an async mode, right? So first the data is written to cache, and then the cache sends back the response to the web server to say, okay, now your data is already written. And then later, when the resource is not so intensive, the cache will just write the data to the database, okay? So this is called write back. So you can also imagine what the problem is, right? The problem is that if the cache dies or crashes before it flushes the data or write the data to the database, then the data will be lost in the cache, right? Because all the data in cache is in memory, right? If the memory crashes or if the cache server dies, then the data will be lost forever, right? So there is risk of losing data with write back. Okay, cool. And there is also another mode which is called read ahead. Okay, So in this case, let's see, we have web servers, okay? We have the cache. Cool. Cache is here. Okay, we also have the database. Okay, cool. Okay, now let's say read ahead means even the web server doesn't need the data yet, but I predicted that a data will be read soon, right? Then we just push the data into the cache. So there will be never a cache miss, right? So let's have an example, okay? Let's say we have two data X and data Y. Okay, we have these two data. And based on the history of the database read, we know that usually when data X is read, maybe after several seconds or after several minutes, the data Y will always be read, or there's a 80% chance that data Y will also be read, okay? So it's a pattern, right? So which is, if data X is read, then there's a high possibility that data Y will be also be read or needed soon, right? So in this case, let's say the web server send a request to request the data X. Then even this web server hasn't read data Y yet, then we just push the data Y. Okay, we just push the data Y in advance to the cache, right? So then later the web server actually read data Y, right? Then there will be a cache hit, which means the data is already in the cache, right? So then we don't need to send request to database, which gives us a high performance, right? So this is why it's called read ahead. Okay, cool. Now we talked about the 4 basic mechanism for cache, right? So the first one is cache aside, the second one is write through, the third one is write back, and the last one is read ahead, right? Now another question or another problem we could have is because cache is using memory, right? And memory is limited, right? So let's say your server only have about 128 gigabytes memory, okay? It's limited, right? So, and it cannot store unlimited data, right? Let's say your memory is is already reaching 128 gigabytes. So what happened? So you don't have extra memory to store extra data anymore, right? So in this case, you need to purge some data from the cache, right? You need to remove some data from the cache, and then you can store some new data in the limited cache, right? So the problem is how do we clean the cache, right? Also, which means how do we remove data from cache if cache is full, okay? Cool, so there are basically 2 very simple algorithms to do this, right? One is called LRU, which is least recently used algorithm, okay? So let's say here is your cache, okay? So you have data A. Okay, and you have data B, okay? So first you access the data A, and then you access the data B, and now you access the data C, okay? So let's say the limit of your cache is you can only store 3 entries in the cache, okay? So this is your cache, the memory limit, okay? Now I read data D, and I want to store it or cache it in the cache, right? So in this case, you want to remove the data, remove one of the data entry from the cache, right? So with least recently used algorithm, you remove the oldest cache entry which you accessed, right? So in this case, cache entry A is the oldest one, right? So in this case, you just remove data A, and you catch the data which you want to cache, the new data, which is data D, right? And now let's say you have another data E, which you want to cache, right? Then you remove data B and you store data E in it, right? And now let's say I read data C again, okay? I read data C again and I need to cache it, okay? So you can see, okay, C is already here in the cache, but it's not the oldest data anymore because you just used it, right? So then you move it to the end of this cache, right? So which means C is the latest accessed data, right? So this is how we do the remove data with least recently used, right? Algorithm, okay? And another one is called least frequently used. Okay, so it's based on frequency. So still, let's say you have 3 entries, okay? Which is CDE in your memory, in your cache, okay? So now let's say cache C, the data C has already been read by 3 times. And okay, 3 times. And this data E is read only 1 time, okay? And this data D is read by clients for 9 times, okay? So now let's say we have a new data, which is data E, we must cache, okay? We want to store some data E, okay? Cool. In this case, we must remove a data from the memory, right? So in this case, we just remove the least frequently used. In this case, E is only used once, right? So in this case, we just remove entry E and, oh, sorry. The new data, let's say it's G, okay? So, and we remove data E because E is only used 1 time, okay? So we just remove it. And then we store data G in this cache, okay? So this is called least frequently used. Okay, cool. So these are the 2 algorithms that could be used to remove data from the cache if the cache is out of memory. Okay, cool. Yeah. So this is it. This is this video. We talked about what is cache and why we need cache because of performance. And also we talked about some cases of how we can store the database data in cache, right? The first one is cache the whole response. The second one is break down the response and cache each single item in the response, right? And also we talked about 4 different mechanisms within the cache itself, which is cache aside, write through, write back, and read ahead. And also we talked about how to clean the cache by removing the old data from it if the cache is out of memory, right? Okay, that's it. And thank you for watching this video and see you next time. And please remember to support me by subscribe to this channel and like this video. Thank you so much. Bye-bye.